company has a managing team and workers. Managing team make decisions and worker notes workers in that company who control the works. So control plane is like the managing team. It coordinates everything. It has four parts: API server, ETCD scheduler, and controller manager. API server is the central communication hub, and ETCD is the database where we store information, and scheduler we assign different tasks, and the controller, it ensures everything is running as planned. Next is worker node. They are like the workers in a company. In it, kubelet ensures everything is running correctly and reports to the master. Next, container runtime. It runs the container. Example Docker. Example Docker. Kube proxy. Handles communication between different parts of the system. Next, its core objects are ports. It is the smallest unit that runs the container. Next, deployments decide how many ports should run. Services allows applications to communicate internally or externally.
Hello everyone, I'm here going to say container orchestration and its user case. Mainly container orchestration uses a system that automatically runs, manages, creates and keeps containerized application. And it also coordinates many containers so they run together smoothly, automatically and without any human presence. What is orchestration means? Many instruments are played together. For example, each instrument has its own timing and its own rules. A coordinator ensures every plays smoothly for its harmony. A container orchestration means coordinating many containers so they run together smoothly, automatically, without human efforts. Why do they use? Why do they need? For example, for logical service, payment service, self-service, notification service, and all, we use containers. A larger company may run hundreds and thousands of containers at a time. Without orchestration, you would need to do it manually. This is actually possible to do. It is also possible, but it takes too much of technical efforts and all. So there we use Kubernetes platform. I'll say about how we are doing it manually. We should start the container, restart them with when they crash. If they crash, we need to restart and add more container during the traffic. For example, I will choose an Amazon let's say, and Amazon. Sales and sales period and all came, there will be too much of users. So that we need more and more containers to stabilize it. We should also, for what exactly does container orchestra do? Running automates deployment. You tell the system the what does container orchestration do? Automates deployment, self-handling, automates scaling, service discovery and network, rolling updates and rollbacks, resource optimization, continuous monitoring and all that. And what are they? Automates deployment means when 10 containers of application, the orchestration will deploy them for use available for use. Self-healing is the time when it crashes, recognizing it and making it work again. And auto scaling it create more containers. Whether it is needed or whether the containers are not in working, they can reduce it. It makes more efficient. And autos discovery and network function stabilizing server needs internal networking and load balancing. And the role updates and rollbacks. You can upgrade your application without stopping it. New versions will be rolled out and slowly. If there is a problem, roll back automatically. That's a resource optimization. You can save CPU, RAMs, and costs. No. Continuous monitoring. You can see whether they are healthy, running or nodes are working properly. And examples for container orchestrations is tools being used most likely is Kubernetes, Swarm, Apache, Mesos, Amazon ECS, EKS, SQS, Google GKE. That's all. Real world example, like I told you, Flipkart, right? There may be connects traffic during the seasonal periods. Millions of users may browse in a minutes and all. No, one day and all. Create more containers to handle so that we need to create more containers and restart failed containers and balance loading, ensure the downtime update service quickly. They are mainly used in Amazon, Flipkart, Myntra and all apps. The main sectors they are used in banking and finance, health system, big data, machine learning, social media platforms, cloud platforms and all. Their container orchestration benefits in summary: automation, highly available, scalability, cost efficient, zero downtime, better performance, and portability. Automation, no need for manual concern management, for high availability, self-handling and fault tolerance, scalability, increase or decrease containers automatically, cost efficient, optimize use of resources, zero downtime, rolling updates and rollbacks, better performance, efficient scheduling and balancing, portable means run anywhere, cloud, on-prem, hybrid. No, no, no.
You guys spoke about orchestration. You learned a lot of into the use cases of orchestration. But I don't know how many of you understood what is orchestration. And one of you answered the question of orchestration clearly, then they have explained it correctly. At least they reached. What exactly is orchestration? Give me one use case of orchestration. I'm by here. That means nobody has understood. What is orchestration?
Container orchestration means coordinating.
I don't like it. Just keep it off and tell me what is your understanding of orchestration. That is something which I need to tell everyone, but I'll say after the seminar.
Container എല്ലാം അതിലേക്ക് വർക്കാവുന്നുണ്ടോ? Container orchestration equal to a system. In a system, whether it is working automatically, whether it is managing all its functions in the if there is a replacement, it should be there. It's a
container orchestration talks about scalability. What do you mean by scalability? When there is a traffic intense, you should balance the load of traffic across multiple containers. That is called scalability, right? When one container crashes, you have to still some other container node should take the responsibility and you should not decline the user. Okay, so that is called error handling. That's not scalability. That is error handling. Okay. Load balancing is when you have more traffic. If one of the container crashes, then the other container node will take the responsibility. Comes up, it takes it. So that's called error handling. Yeah, you take over the responsibility. User is not declined. The request is still not declined. So that's the second one. Third one is, what is the third one you said? Yeah, the resource usage. If the application is not being used by too much requests. Say for example, admission സമയത്ത് കോളേജിൽ there will be more requests coming to that part of your logic process. Admission process handle ചെയ്യുന്ന നിങ്ങളുടെ function software എഴുതുകയാണെങ്കിൽ ആ software handle ചെയ്യുക the number of requests hitting that part of your container will be more during the first 3 months when the college starts admission, right? So once the admission is closed, that part of the logic is never disturbed or maybe rarely disturbed the rest of the year. So you can reduce all the resources of that container. Based on the usability of the process, you can manage the resources within a container and spare items. This is one other way. ഇത് എല്ലാം ഓർക്കസ്ട്രേഷന്റെ ഭാഗമാണ്. ഇതൊക്കെ ചെയ്യുന്നത് ഒരു മാനേജറാണ്. That manager looks into every container, how the containers talk to each other, how the containers share data, how the containers optimize performance, how the containers handle the errors, how the containers manage the data and code. All these things are controlled by a manager, and you have to write configuration files or application logic to tell the manager how to do it for your business. So orchestration is technically automated by Kubernetes manager, and programmatically the logic, business logic, you have to tell the Kubernetes manager what is your need. Flipkart in the orchestration need, Ayurveda, Swiggy operations need, orchestration need. So it varies from business to business. That's how you should make use of your automated orchestration. Okay? Okay, fine. Good. Who else? Okay, what else? Steve. Go ahead. Yes.
So today we will be explaining what CI/CD means, and we are going to show you a little example of implementing a CI/CD in AWS, and also we are going to show you a simple CI/CD code actually Cyanify in GitHub Actions. So in order to teams are expected to deliver their features quickly. In traditional way, it takes manually deploying. So it takes some time consuming and there are conflicts like unstable releases like that. To solve this problem, industry adopts and adopts practice like the main pillar of this CI/CD is automation. Like continuous integration means practice of frequently merging code changes into a shared repository. That means a developer writes a code and it is tested and integrated with the main project. So each line and triggers automated the process that pulls the latest code with the application, run the test, and reports result to developers. The main goal is to detect issues early and reduce integration problems and maintain a stable code base. And the key benefits is faster feedback to developers, early bug detection, less time spent fixing bugs, conflicts, and continuous delivery. After the integration, it verifies the continuous delivery ensures that application is always in a deployment state. That means deployment to production is still a manual approval step. But everything else like building, staging, like that will be automated. After that, with deployment, this goes to a further step like every code can change the pass to automated test in automatically deployed to production with no manual intervention. Like that, the key benefit is faster release cycles, fewer human errors, and more reliable deployments. Then why CCD matters? Reduce risk by catching issues early, increase development speed, improves product stability, enable rapid innovation.
CI/CD pipeline. If you look into the deployment of the process deployment, first the developer has to push the code in CI. So with the help of tools, there are many tools like NPs, GitHub, Action. There are lot of tools like that. Then they will check the safety and ensure that it is okay there. There will be fewer bugs or before they go to live. Then this pushes into the system operation with the check the and updated the version of the code, and then it will be pushed into the app CD, which notify the changes and update into Kubernetes deployment. If you look into example of AWS with the AWS pipeline, first the developer has to push the code into code commit, which the code commit will save and places the code in a secure place, and then and update the changes. Then it will be pushed into code for the application, and the application is built, and they will run the server testers to look if there is any bugs or any protocol. Then it will be pushed into code deployment, where then they will deploy into servers like EC2 and EC3. This ensures the high reliability in code, and there will be fewer bugs before reaching the user. They also provide the deployment like canary and groups that some of the users can test canary the version before it reaches the full deployment. And if there will be any bugs or any problem, they will stop the application and they will be roll back to roll back. And by this and the application portion will be.
How do you do the rollback?
Basics of the pipeline.
Yeah. So if something
And after
creates an issue,
so they will be rolled back.
what will you do? Code set?
Yeah, code say not subjective portion of the application. If there will be any bugs and user doesn't.
Yeah. My question is, how do you roll that? You executed a pipeline, so you have actually built the pipeline. And at the way you push it, now how will you roll it?
I think because there's one of the
Because
it's a testing.
Like when you test something and there's an error, you stop the process.
that is not a rollback. That is actually
ഇവനും അതിനെ പിടിക്കുന്നില്ല.
you still can do a rollback, but there is a process of that. Okay, fine.
എന്തിനാണ് ഇതിനകത്ത് ആക്സെന്റ് കൊണ്ടുവരാൻ നോക്കുന്നത്?
Got it. Fine. Thanks.
So here we have a simple example. Like what we are doing is we are implementing a CI/CD pipeline to that, which is actually free. We can use it in a public repository. Every one of us can do it. Very easy and very free. So the pipeline structure, as you can see, this is a YAML file, and it starts from like first we name it as a simple CI/CD pipeline. This is nothing but a name we give to this pipeline so we can recognize it itself. And then we put a condition like on push branches main. It means we will start the workflow whenever the code is pushed into the repository and the main branch. And then what we are doing is we are doing defining a job, and job name is build, test, deploy, and that's nothing applicable. It's just a name we are giving to the job, and we are giving it a system called Ubuntu latest. What is it is actually, but it's a temporary mission that Docker provides us, so we can run the pipeline, and it's just a virtual mission there, right? So we are selecting an Ubuntu mission for that. And next, we are starting the steps. And the first step is check out code, it's just a name. And what we are, it's a built-in check actions, and we are using that actions to check out the code. Whenever a code is deployed, whose single repository is triggered, and the code is taken from there, and it is put inside the runner. And then we install the dependencies using this run npm install, as it's a JavaScript Node.js JavaScript application, and it will according to what your application is. And then we run the tests, and it's all automatic. It's all automatically goes out. And the last step is they will test task. We will deploy it to an S3. And in here also, what we're using is just a built-in GitHub Actions line just before it into the AWS S3 bucket. And then we have some basic deployment configurations, and here we select what's the name of our bucket and which AWS region we want to put it in. And as you can see here, this is actually the AWS credentials. And if you have noticed, you can see the credentials are not visible here. It's actually stored in GitHub secrets, so it is secure and not visible in the file. And that's it. You can implement a simple CI/CD pipeline for free. It's a public repository using the GitHub Actions. But if it's a private repository, you have some limits. I think you have some limits or something. After that, you have to pay for it. And that's your solution.
meeting നോക്കാം.
Okay. Sorry, I missed the now part. Okay. Fine. Any questions? So, what do you guys understand from this pipeline code? What exactly is this pipeline code? tell me what is step? That's a high level. Tell me a lower level. From programmer's point of view, what is it doing? Okay. It's plain English. If you read it, you'll understand. Come here. And you will read it and tell me what it is. It's a job.
Even as a job, it's from by deploying. Like you get test case. Deploying by
There is no test case.
so like test.
What is the first step?
First step, so it's user branch, pushing a branch, like
First steps from steps section. What is first step? I'm asking from here. I'm asking from here.
usually checks the code.
What do you mean by check out code?
There might be a particular
No, it's not. You're checking out software code from here. Pulling it out. Fine. You guys need to listen more. Who else can answer the second thing? What do you actually mean by install dependencies? Who can answer it here? What do you mean by that install dependencies? The steps. Install dependencies in the steps. And the other thing, what actually your understanding about that line? Which version of? No, I just want to know about that line. Install dependencies. First one is check out the code. Then you use an action for that checking out, which version, and then you are actually saying which install dependencies. What are the dependencies? What can be the dependencies for a code checkout? NPM is a library in Linux to install. Just like in your command window or PowerShell in Windows, you are using a pip. Equivalent to that is NPM in Linux. It's a command. It has got nothing to do. So you guys understand the logic of what you mean by install dependence. Suppose your code uses Flask. Suppose your code uses Python. Install dependencies will install that in that particular machine. Target machine. Everything is set first. You have a container ഉണ്ടാകും നിങ്ങളെല്ലാം download and install ചെയ്യുന്നില്ലേ ആദ്യം വേണ്ട softwares, then putting your code, then compiling it, then running it. That's what this code is doing. It is pulling out the code from Git. First step is it is pulling out. Check out the one, it's taking out from Git. Then it installs the dependencies. What are the dependencies? It's reading from the configuration of your CI/CD. The dependencies can be whatever the stack with which you are developing. SQL Server ഉണ്ടാവാം, Linux ഉണ്ടാവാം, operating system എന്താണ്, UI എന്തുകൊണ്ടാണ് build ചെയ്യുന്നത്, JavaScript version എന്താണ്. It is asking everything. Those are all your dependencies. So you are installing all those softwares in that machine, target machine where you are going to run the build. Then installing all those dependencies. Then finally you are running your code. Then you are running your test, automated test. And then finally, if your code is compiled, built correctly, your tests are all passing, then you are pushing it into Amazon resource. ഇതിനെക്കാളും simple ആയിട്ട് CI/CD pipeline explain ചെയ്യാൻ പറ്റില്ല. That's what they are struggling to explain. Please pay attention. Right? So finally it goes in, you deployed it, And finally, it says that in which region of AWS it goes and who has access to it. What is the username and password? This username and password is what your pipeline uses. You can see, can scroll up a little. This username and password, key and secret. This is what your pipeline uses to connect to your Amazon account, to push things, because it also needs a login. Either it's a user or it's a process, system needs a login, authentication. Right? Login ചെയ്ത് നിങ്ങളുടെ കോഡ് ബിൽഡ് ചെയ്ത് ഓട്ടോമാറ്റിക്കായി കണ്ടെയ്നർ അല്ലെങ്കിൽ വിഎമ്മിലേക്ക് പുഷ് ചെയ്യാണ് ഇത് ചെയ്യുന്നത്. That's the whole logic of a pipeline. So very simple thing, but module 4 of cloud, I'm here to explain this. This way to make my job a little simple, but still, this is the whole context of a pipeline. It can be very complex. If your dependencies are complex, if your software is enterprise level with hundreds of modules, then it's complex. If you have event-based message queuing, then it's complex. Then your pipeline becomes extremely complex based on how you designed your software. So that's where the challenge for DevOps engineer comes in. Right? Is that clear? Okay. Thank you. Who is the
കണ്ടില്ല ഇതെന്താ സെറ്റ് 3 ഇതല്ലേ ലാസ്റ്റ് ഇനിയുണ്ടോ യെസ് 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 ബിഗ് ഡാറ്റ ലാസ്റ്റ് ദ ഫസ്റ്റിലേക്ക് നോ ഒബ്ജെക്ഷൻ സാർ യെസ് ചുമ്മാ നേരം വയ്ക്കാലോ
Fine.